In this video, I'm going to show you how I built a really nice minimalistic looking mechanical keyboard with the help of a 3D printer. To start this project, I'm going to download the STL files for the keyboard frame that I designed. If you want it, the link will be in the description. Then, I sliced the STL file to produce the G-code, and off to the printer it went. I'm using a 0.8mm nozzle on the printer so that it prints faster. And here are the results. As you can see, the print quality is pretty good. The visible part looks smooth and clean. Although there's some minor imperfections, those can be filed off easily. And here's the other part. Now all I need to do is to join them together. For that, I'll be using super glue. Apply the glue to the edges evenly, make sure to coat the entire contact surface, and then simply join them together. I'll also be using some clamps to hold them together while it dries. After the glue has dried, remove the clamps and I'm left with a really nice keyboard frame. Next thing to do is to install the switches. You can use any switch you want, but I'm using a JBrick T1 switch. Not only it is cheap, but it also gives a really nice ductility. I bought 68 of them for only 20 bucks. Now because this frame is 3D printed, some holes might get too tight as you can see here, so I simply filed them until it fits. I then simply installed the rest of the switches. And this is the end result. As you can see, it looks really nice, especially with the switches installed. Next, prepare some wires. I'm using a 0.5mm solid wire, and then some diodes. I'm using a 1N5819 diode. The reason I chose this diode over the usual 1N4148 diode is because it has a lower power voltage, and it is also cheaper in my place. Then, you would need a microcontroller. This is STM32F401CC. I'll explain about that later, as the next thing to do is to solder them together. Now I do apologize that I couldn't show the rest of the soldering process together, as it's really hard to solder on camera. And here are the schematics. I will also provide it in the link below. And after everything is put together, it should look something like this. Right, so this is STM32F401CC. The reason why I chose this over the famous blue pill is because it has a USB Type-C port. Above that, it is also more modern, has more peripherals, and a better CPU. But I don't really need that extra power for this project. But since the last pandemic, the price of the blue pill has quintupled from $2 to $10, whereas the price of the F4 only raised from $4 to $6, which makes the more powerful board now cheaper than the weaker ones. Yeah, it's amazing to see what a pandemic can do. After soldering them together, I will need to flash the microcontroller. So on Platform.io IDE, I cloned the Git project with the link from the description. Next, I connected my ST-Link programmer to the microcontroller and clicked on the upload button from Platform.io. It should start to compile and flash the microcontroller. When flashing the microcontroller, the LED on the programmer should blink. And now the keyboard should be working, as you can see here. I know what you're thinking. Where does the magical keycap come from? Yeah, I know I'm kind of unorganized, but I'll show you later after printing the back cover for the keyboard. Next, I printed a set of CoStar style stabilizers. Again, the link for that is in the description below. I only installed the stabs on the spacebar as the others are sturdy enough. The next thing to do is to get some solid steel wire and bend them until it looks like this. Then loop the contacts and fit it to the stabilizers. Now let's talk about the keycaps. As these are also 3D printed, it was also too tight to fit. You can jam them together, but it might break the switch. For that, I prepared some cheap switches as sacrificial hole enlarger. And I basically forced the keycaps in and out until it gets loose. And now it should fit easier. Then get the other pieces of the stabs, install them to the spacebar and loop the contacts. Then slowly fit the wires to the slots without bending them too much. Then I installed the rest of the keycaps. Now the project is complete. If you like this video, please give it a like, share and subscribe. That would be greatly appreciated, and thank you very much for watching.